Good afternoon, my dear student. Today we will perform a new experiment. We will experiment number 7, determination of different parameters of two-port network. Okay. In last class, in last theory class we have covered this topic. Okay, two-port network, and we have derived the expression of z parameters or impedance parameter. This parameter is also known as open circuit impedance parameter. Now you will perform this experiment. You will the values of z parameters experimentally. So let me share with you the link which is required for today's experiment, Okay, you use this link to perform the experiment number 7, determination of the different parameters of two-port network. To perform this experiment, everyone use the link I have shared with you through chat box. You visit to virtual labs site of IIT KGP. You will see a screen where you will find out an option that is simulator. You just click on the icon simulator. Everyone, please click on the icon simulator. After clicking on the icon simulator, you will find a new screen. You will find a new screen where you will see the two options. One is click here to perform the experiment, and another option is click here to study proper circuit connection to perform the experiment. These two options are given just below the statement link to the simulator. Okay. So first everyone use the provided link and visit to IIT KGP site. After that, you click on the icon simulator and you will find a new screen where you will see two options just below the link to the simulator statement. These two options are click here to perform the experiment, and another one is click here to study proper circuit connection to perform the experiment. You can click on the second option to understand the proper circuit connection if you want or if you wish. Otherwise, you can click on the first option, click here to perform the experiment and proceed for the experiment step. Okay, anyone can click on the second option to know the proper circuit connection, and after that you click on the option click here to perform the experiment to execute the today's experiment. Okay, to execute the today's experiment. So now you see the proper connection of the circuit, and then you click on the first option. Okay, now let me show you the circuit diagram and steps or instruction required to perform this experiment. You see the present slide where I have given the circuit diagram for today's experiment. The objective of this experiment is to Z parameters, calculate the values of Z parameters of a two-port network. And before going to perform this experiment, I suggest all of you read out the instruction carefully. Read out the instruction carefully and then you proceed for the experiment. Okay, so you just read the instruction carefully. First option, step is enter the supply voltage and frequency. There are two circuit. There are two circuit in this slide. One is M network and another one is N network. These two are obviously two-port network because you see that there are there are total four terminals. One input port, another one is output port. It is denoted. Okay, you just see input port and output port. For M network as well as for N network, there are two port, input port and output port. Therefore, in this slide, we can see two network. One is M network and another one is N network, and obviously these two are two-port network. Another thing, you just see that one is pure resistive network. Pure resistive network. The M network is pure resistive network because it consists of only resistance element. Okay. On the other hand, the N network is a reactive network because it consists of capacitor and inductor elements, and you know that resistive circuit consists of only resistance and reactive circuit consists of only storing element, storing capacitor and inductor. First step. Second step, enter the parameters of M and N network and switch on the supply. Third step is M and N network can be used as separately or in cascade. Select the desired network by choosing the corresponding tab. You will see three tabs in the next slide. Okay, I will show you the circuit diagram where you can find out three tabs. One is for selecting the M network, another one is for selecting the N network, and MN tab which actually used is to select the cascading network of M and N. I will show you in next slide. Then you can select the parameter using the select parameter option under control section. Then you can select the port, input port or output port by using the port selection option, and finally you click on simulate to observe the value of voltage and current and corresponding parameter of the network. Okay, so I suggest all of you first read out the instruction carefully. Read out the instruction carefully. Then you proceed for this experiment. Okay. Okay. And let me tell you the different parameter of Z. Okay, Z parameter basically consists of four parameters: Z11, Z12, Z21, Z22. That means true driving point impedance, input port driving point impedance, and output port driving point impedance. Z11 and Z22, and another two, Z12 and Z21, are transfer impedance. One is forward transfer impedance and another one is reverse transfer impedance. We have derived their expression, okay, in theory part, but I have given here. You just see the expression of Z11, Z21, Z22 and Z12, and you just remember, or you can easily understand how do you calculate the values of this parameter, what are the conditions required to compute the values of this parameter. You know there are two ports, and this parameter is known as open circuit impedance parameter. Impedance means what? The ratio of voltage and current, and its units obviously will be ohm. Okay, ohm. And another thing, you will see that if you want to calculate the value of Z11 or Z21, that time you need to open the output port. That means you need to make the output current equal to 0, I2 equal to 0. On the other hand, if you want to calculate the value of Z22 and Z12 values of this parameter, that time you need to supply the input voltage to the output port, and you need to open to make the input current is equal to 0, I1 equal to 0. So you just see the case 1 and case 2, and then you can easily understand the steps which are required to compute the values of Z11, Z12, Z21 and Z22. Okay, this part you have covered in your theory class, but I have given here, okay, to have to easily calculate or compute the values of this parameter. Now let me share with you the circuit diagram which is required for computing these values of this. I already told you that you just read out the instruction carefully which are given under procedure section, okay, and then you perform the experiment. Okay, so what you will do, first you choose the values of Z capacitance and inductance parameters. Okay, in this case I have considered a cascading connection of M and N network. You can perform this experiment choosing either only M network, or here I have given a combined circuit of these two network M and this is two-stage network. Two-stage network. Everyone must perform this experiment, okay, and submit the lab record or lab report. Okay, in your lab report you must mention the result for this combined network cascading connection of M and N network. No need to mention the values of Z parameters for single stage network M or N. You must parameter for this combined network or two-stage network, which is a cascading connection of N and N network. You see, M network is purely resistive network and N network is a reactive network, and which one I have given here, that is a combine of these two. Of M network is connected to network. That's why this type of connection is known as cascade connection. Cascade connection of the network. Okay, so what you will do, first you select the values of the registered capacitor and inductor element as you want, as you wish. Okay, after that you switch on the circuit, switch on the power supply. Okay, here you see that there are three tabs. I already told you that M network, N network, M N network. If you can get only a pure resistive network.
If you select the middle one, okay, N network tab, then you will see a reactive network, which actually consists of only this capacitor and inductor elements. Okay, and here you see I have selected the A main network. That's why you see this part to resistive network, and that part actually corresponds